Hey everyone. So today we're going to be doing the cellular respiration in germinating peas lab. All right, so I'm going to go ahead and share my screen and we will start going through this. So the different thing about this lab that we've seen as compared to other labs is there's a couple days of setup. So I've done everything ahead of time. The 2 days of setup. So we're going to be starting with activity one, but I'll go through what the setup is. So you can find this on our e-learning page, this document that goes through the overview, objectives, and the activities. So the overview of this is to really begin to get into understanding the cellular respiration, particularly aerobic respiration. All right. So I'll let you guys read through the overview, but the objectives of this are to describe the 3 stages of cellular respiration, explain the roles of oxygen and carbon dioxide in cellular respiration, prepare and execute an experiment to observe and measure the rate of cellular respiration in both germinating and dormant peas, and to analyze data collected using a simple respirometer. So we're going to make a respirometer, and then we're going to do some experiments. And the time requirements for this, so prep day 1 is about 5 minutes, prep day 2 is about 15. Activity 1 is going to be 60. And activity 2 is going to be 40. And then in terms of PPE or personal protective equipment for the lab, everyone should have their goggles, their gloves, and an apron. All right. So I'm going to give you guys a couple minutes to go through the background now. Go ahead and read it through. It should all be review from the cellular respiration topics of class, but this is just good reinforcement. So go ahead and pause the video, and then once you've read through the background, meet me with the prep steps. All right, perfect. So you guys are unpausing the video. You've read the background. Now we're ready to get into the experiment. So pretty much for this, what we're going to need is you're going to need all the materials from the lab kit specific for this lab, as well as your 100 milliliter graduated cylinder, your thermometer, and your forceps, which are at the other end of the table. So I'll grab them later. And then some other things you need a disposable aluminum baking pan, or I have a roasting pan. So you can use that as your water bath. You need 3 nickels, a timing instrument, so a cell phone would work. Food coloring. I'm going to do this without food coloring myself because I don't have it, and I'm not buying it simply for this lab. And I would suggest that if you don't already have it in your house, you don't need to purchase it either. I'll show you how to get around that. Plastic cup, which you need for the preparation steps. Paper towels, which you need for the preparation steps. Resealable bags, prep step, scissors, and water, either bottled spring water or distilled water. Just needs to be non-chlorinated. So tap water isn't ideal for that. So yeah, goggles, gloves, apron. The biggest thing for this is make sure that you're wearing that when you're working with the potassium hydroxide. Everything else is pretty, it's not going to harm you if it gets on your skin. You're just really working with water and peas. But the potassium hydroxide is corrosive to your skin. It can really do damage. So when you're working with that, make sure you have your gloves and your goggles and your apron on, and that you're working on a protected surface. All right, so prep day 1. So this is 2 days before actually conducting the activity. You're going to place 50 garden peas, which are dormant, right? Because they're the ones in the bags, right? They're not exposed to any water or anything like that. So they're considered dormant. Place them in a small plastic cup. Cover the peas with the non-chlorinated water and allow them to sit overnight. I'm going to give you a little bit of a warning here about why you shouldn't use tap water for that. So then the next day, so yesterday, right, if you're watching this and are going to be completing activity 1, you would now remove the water from your hydrated pea seeds and place the seeds on a paper towel that is saturated in non-chlorinated water. And each seed should be in direct contact with the paper towel. You're going to fold the paper towel up and you're going to place it into a sandwich bag or some sort of sealable bag overnight. Okay. And then you're going to prep your water bath. So again, I'm using a larger roasting pan rather than 2 9x13s. And you're going to fill it to about 1.5 inches of tap water, and you're just going to allow it to sit overnight so that it acclimates to room temperature. All right. So with the prep out of the way, we're going to jump right into activity 1, the experimental setup for cellular respiration, or we're going to be assembling our respirometer. So the following materials are going to be needed. So we have our 3 glass vials, flat bottoms. We have our 3 nickels. We have scissors. We have our parafilm squares. We have our rubber stoppers. We have our pipettes. All right. So let's just jump right into it. Place 1 nickel in the bottom of each of the glass vials. Sure. So if you're using a nickel, they should fit perfectly. I don't know why you couldn't use like a dime if you don't have a nickel, but a quarter won't fit. All right, so take 2 squares of parafilm, cut each square in half to make a 1x2 strip. Use 1 strip for each of the 3 respirometers. All right, so the nice thing with parafilm is they have lines denoting the squares, so we're just going to cut them in half. So to make the squares, and then we're just going to cut these squares in half themselves. Perfect. Easy to do. All right, to assemble the top of the respirometers, gather 1 rubber stopper, 1 ml glass pipette, and 1 strip of parafilm. All right, so we have all those ready to go. Remove the wax paper from a strip of parafilm. Tightly wrap the strip around one of the glass pipettes, approximately 1.5 inches from the blunt end. And so if you have questions on that, you can refer to figure 3. All right, but what we're going to do is we're going to open up our glass pipettes, potentially. There we go. All right, so real thin. And then we're going to take a piece of parafilm. And make sure you're just grabbing 1 piece. The waxy ends will stick together. Okay. Take 1. And we're going to wrap it, let's say, 1.5 inches from the bottom. And on the picture, they kind of give you like a way to judge that. All right, so about 1.5 inches. So I'm just going to go right at the yellow line at the bottom. Okay. Now the thing with parafilm, when you wrap it, is parafilm is really stretchy, but it won't stick well unless you're really stretching it out. So, you know, be generous with stretching and wrapping. The good thing with that is the more you wrap it around, the thicker it's going to be. So the tighter seal you're going to generate, which is important for this. All right, so you should have something that looks like that. Yeah. All righty. All right, so then we are going to hold the pipette at the parafilm and carefully insert the blunt end of the pipette through the hole in the rubber stopper. This will form an airtight seal. All right, so we have our rubber stopper, and again, refer to the image, right? So narrow sides down because it's going to go into the vial. So we're just going to kind of wiggle it on through. Again, we want an airtight seal. The biggest thing here is, right, you don't want to break the pipette. that would be bad. So just be gentle and you should be fine. But you should have something like that. All right. And we'll actually test later on whether we're airtight or not. Yeah, they give you a little bit of a caution. This is a glass pipette. So if it does crack or snap, you can cut yourself. So please be very careful with that. Okay, so now we're on to creating the water bath. So take out the water bath that was filled the previous day. The water in the bath will buffer the respirometers against temperature changes and ensure a closed system inside the respirometers during the experiment. Okay, so here we go. So we're going to test if the seal between the stopper and the pipette is fine. After setting up the rubber stoppers and pipette, plug the top of each vial with one stopper and completely submerge the respirometer in the water bath for 20 to 30 seconds. Okay, and check for leakage. Okay. Let me see something here. Okay, so I'm gonna put this in. And what's it say? Submerge. If contact between the stopper and the pipette or stopper and the vial is leaking, water will begin to enter the vial. So completely submerge and look for water going into the vial. Water shouldn't go into the pipette because pipettes work through drawing up the water with pressure. So there is, let's see, I'm actually correct here. Yes, there is no water in the vial. So this is good. Okay. So we have one that is good. All right, so the seal is good. Place the thermometer in the water bath. Check the water temperature 2 or 3 times before starting to experiment to make sure that it's stable. So I have to find where I put my thermometer. There we go. So temp wise, I'm pretty good. I'm right about 25, which is what's considered normal room temperature. So we are good to go. Okay, so I'm just going to put the thermometer away so it doesn't get busted. All right. So setting up, well, hold on, let me, am I supposed to be doing this? We're supposed to prep all of them? No, just says prep one for now. Okay. All right, so setting up the P's and beads. Add 25 milliliters of non-chlorinated water to the 100 milliliter graduated cylinder. Slowly drop 25 germinating peas into the graduated cylinder. All right, so I need non-chlorinated water and my germinating peas. All righty. So my germinating peas in the bag. First thing I'm doing adding 25 milliliters of water into the 100 milliliter cylinder. And I'm just doing this over my water bath so that I don't spill water all over my table and laptop. That would be fun. Okay. "25 milliliters, slowly drop 25 germinating peas into the graduated cylinder." Okay. We gotta open these guys up. Now remember, the germinating peas are the ones that you had in the bag overnight. The dormant peas are going to be the ones that you didn't do any prep with, the ones that are just left in the bag. Yeah, and you can see, right, your peas will have like sprouts coming out of them, right? Because they had some water, so they're growing. 25, 1, 2, 3, 4, 5. 10. 15. 20. 20. Okay. Put the rest of them off to the side. Observe the final volume after adding the piece to the graduated cylinder and record that value in data table number 1. All right, so my final volume here is actually right around 35. So 25 P's, increase the volume of around 10 milliliters. All right, so you'll record that in data table 1. Determine the volume of water that has been displaced by subtracting the initial volume of water. Volume initial is 25 milliliters from the final volume after adding 25 P's. The difference in volume is equivalent to the volume of the germinating peas. Record that volume of germinating peas in data table number 1. Yeah, so volume initial is 25 milliliters. My volume final is 35 milliliters. So the volume of the germinating peas then based on this difference would be 10 milliliters. All right, and that's what you would record depending on what you want to do. Okay, so remove the germinating peas and place them on a paper towel saturated with non-chlorinated water. Okay. So grabbing these back. I need to get the peas out of here. So what I'm going to do is I'm just going to dump the water to my water bath, then dump the peas back onto the paper towel. Okay, we're going to get those out of the way. And then I am refilling the graduated cylinder with 25 milliliters. So I'm going to do that over my water bath again. Spilled that everywhere. That went a little bit too much, so. Okay, so I'm at 25. Slowly drop 25 dry or dormant peas into the graduated cylinder. Okay, gradually add beads to the graduate. All right, so I'm putting 25 of these guys, the dry Alaska peas, into the graduated cylinder. So 6 or 5, 6, 8, 9, 10. 12, 13, 14, 15, 16. 18, 19, 20, 21, 22, 23, 24. Okay. I'm gonna put those in there. Peas, dry peas in there. All right, then gradually add beads to the graduated cylinder containing dormant peas so that the final volume equals the final volume measured previously for the germinating peas. Adding beads to the graduated cylinder with a smaller dormant seeds ensures that the respirometers contain equivalent volumes at the start of the experiment. All right, so now we're going to add our beads till we get to the same volume, which I had was 35. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, so 22 beads gets me to the same volume. Okay, 22 beads. So remove the dormant peas and beads and place them on a dry paper towel. Keep them separate from the sample of germinating peas. Record the volume of the dormant peas and beads in table 1. Okay, yep. All right, so do that. I need a new paper towel. Okay. Water out. Okay. I'll keep that separate. We'll put that on this side. Okay, then we're going to, so we're at step 11, refill the graduated cylinder with 25 milliliters. Over again. Sort that out. Okay. Okay. Gradually add beads so that the final volume equals the final volumes of the germinating peas and the dormant peas plus beads. All 3 groups should have equivalent volumes. Remove the beads, place them on a dry paper towel, keep them separate. All right. Oh, this is going to be a lot of beads. So 38 beads got me to the same volume. Now remember, yours might be slightly different, and that's okay. 1 sec, I need another paper towel. Okay, move the beads, place them on a dry paper towel. We'll do that now. These can sit right here. Okay. All right, so caution. It is essential to wear personal protective equipment for all subsequent steps of the activity. First, put on the apron, then the protective goggles, and then the safety goggles. Do not proceed to the next step without wearing your PPE. Absolutely. So, main reason is you're getting into using the potassium hydroxide solution here. All right. So, all right. So let's read ahead and see what we need to do. And then we'll come back and we'll go through it all. All right. So we're going to place an absorbent cotton ball on the top of the nickel in the bottom of each respirometer. Okay. So the absorbent cotton balls are the ones not in the bag. Okay. They're the ones that were provided loose. Use a plastic graduated pipette to saturate. So these guys. To saturate the cotton with 2 milliliters of 15% potassium hydroxide solution. Carefully expel the solution from the pipette to avoid getting KOH on the sides of the glass vials. If KOH does end up on the side, dry the vial with a paper towel and dispose of the paper towel in the trash. It is important that the amount of cotton and KOH solution added to the vials are the same. Place a small wad of dry, non-absorbent cotton, which is this guy, on top of the KOH soaked absorbent cotton. This will prevent the peas from being in contact with the KOH solution, which would damage the peas and could affect the results. Then you're going to place 25 germinating peas into the one of the vials, typo. Place 25 dormant peas into the other vial, place third. Insert a stopper into the pipette into each of the 3 respirometers. The stopper must fit tightly. If any of the respirometers leak. All right, so this is what we're going to do. All right, what we're going to do is we're going to prep our respirometers first, because there's no reason why we just didn't prep all of them in the beginning. So we're going to do that first so that we can do this without gloves. Right, so again, we're going right at the yellow. And we're going to check all of them and make sure that they're not leaking now. Got a little rippage, that's okay. Yeah, so if your parafilm rips like mine just did, don't worry about it. Just stretch it out, keep going over and wrapping. Because we don't want to notice that these are leaking. When we're actually running the experiment. Okay. 1. We have our 1 for before, so that's 2. Third one. You're wondering why I have a flower balloon behind me. My daughter is really into balloons right now. They keep her attention for a very long time. So balloons are all over the house. I feel like I'm in the movie It or something. All right, we're gonna prep the third pipette. But when you have a baby, if you're a parent, you already know this. If not, you'll see when you are a parent, whatever keeps your kids' attention, that's what you go with. It's weird balloons. It's weird balloons. All right. Get this one situated. Again, be very gentle. You don't want to break your pipettes. All right. So the other thing that we can do first, so we can put our absorbent cotton down onto the nickel. And if you can't reach the bottom, you can make sure that it sits at the bottom by just using the blunt end of one of these guys. Okay. That down. That's 2. That's 3. All right, and we'll get our absorbent cotton ready to go. Which is literally just sheets of cotton. But we can rip it. Remember, we're going for small wads here. Something about that size should be fine. You don't want too much. All right, so we're good to go. So what we're going to do is we are going to get our gloves on, get our goggles on. And then apron. It'd be nice if they took into account giving you these gloves that people have different sized hands. But what can you do? Get our goggles on. All righty. So place absorbent cotton ball at the bottom of each of the vials. Done. Okay, using the graduated cylinder. So now we're going to be working with the potassium chloride. So these guys, if you look along the side, right, each one of these is 1 milliliter. If you go up to the top here, so without the water going into the bulb. So you need to do 2 of these onto each one. Okay. We're just going to be very, very, very careful. Okay, so for some reason they give you a squirt bottle and then they want you to do a pipette. So that's not going to work. Okay, that makes no sense, but that doesn't come off, does it? Nope. Okay. That's fun. All right, let's see here. So we need to put the potassium hydroxide into something and then transfer it out. So let me get we'll be right back. All right, for this, I'm just going to use a plastic cup. Slow going, but dump enough out. Let's see how much that gets us. All right, so remember, we're doing 2 mils per. The goal is to not get any on the sides of the vial. Go right onto the cotton. Just take your time with it. There should be no reason why you have to wipe the sides of the vial. It's nice steady movements, slow ejection of the liquid. The KOH. Okay. 2 vials done. Okay, 3 vials done. So make sure your lid is back on the potassium. Whatever's left, we're gonna put that right off to the side. All right. So now we're going to place a small wad of cotton of that. And again, you can use the blunt end of the pipette. Just don't touch the tip if you're doing that. Because remember that it's just in potassium hydroxide. Okay. We have our 3 vials. We are now going to place our dormant peas in one, our beads in one, and our germinating peas in one. I'm just going to put the potassium back into the little plastic bag in which it came. Good and sealed. All right. The beads are going to go on one. I'm going to drop them everywhere. Beads are in one. We'll grab our dormant peas and beads. They will go into the other. It's down a little just so everyone can see what I'm doing. Instead of just watching my face as I put beads and peas into things. Okay, and then the last one are the germinating peas. Again, we want 25. They fit as well because of their little tails. All right. So insert a stopper with a pipette into each of the vials. The stopper must fit snugly. Yep, so this one is going to, don't be afraid to kind of push. You'll notice with the germinating peas, they have the tails and that just takes up a lot more like free space. But don't be afraid to push down a little. You need it to be snug. All right. All right, so all three of our respirometers are good. Right, it'll look like something like that. Carefully lay the three assembled respirometers on the table or other flat surface without disturbing the moistened cotton ball and seeds. And position the respirometer pipette over a paper towel. Add some food coloring to the tip of the pipette by hanging a drop of food coloring from the food coloring bottle so that the drop touches the tip of the pipette and allow capillary action to pull the drop of the pipette in. Yep, so what you'll do is you'll just lay this down, put the little dab of food dye right there if you do choose to use it, and then it'll draw into the pipette. And what that's going to allow you to do, if you do choose to use it, is visualize volume changes in the pipette during the experiment. The other thing that you can do is if you don't have that, which I will be doing, is using just the flashlight on my phone, and you'll be able to observe changes in volume. All right, so place the three respirometers into the water bath in an upright position with the pipette tips resting on the lip of the water bath. Allow the respirometers to equilibrate for 5 minutes. This will allow the intern, so I'm just going to read through this and then we'll do it. Allow the respirometers to equilibrate for 5 minutes. This will allow the internal temperature of each vial and its contents to reach thermal equilibrium with the water in the bathroom with each other. If any of the respirometers begin to fill with water, there's a leak and the experiment must be started over. Yes, which is why we check them all ahead of time, right? I love that they don't tell you that till now after you've already filled them. Check them all ahead of time. After the equilibration period, submerge all the respirometers, including the pipette tips, in the water bath. Position the respirometers so that the scale can be read on each of the pipettes. Yep, so twist them just so you can see the numbers on the side. Do not put anything into or take anything out of the water bath until all necessary measurements have been recorded. Allow the respirometers to equilibrate for another 5 minutes or until the dye on the respirometers containing the germinated peas has passed the 0 mark on the pipette, whichever is later. All right, yeah. After these equilibrium periods, observe the initial volume reading on the pipette scale. Okay, so actually it looks like here you are going to want to use dye if you have it. All right, so I probably do have it somewhere, but because it's going to help you observe the differences in the gas. So it's worth doing if you have it. Yep, so after these equilibrium periods, observe the initial volume reading on the pipette scale of each respirometer to the nearest 0.01. Record this information in data table 2 for time 0. Observe and record the temperature of the water bath. Yep, so if you can, just kind of prop up your thermometer on the side. Take observations of the volume on the scale of each respirometer every 5 minutes for 20 minutes and record this information data table number 2. Record the temperature of the water bath for each of the 5-minute intervals. Yep, so every time you're going to be taking the reading, recording the temperature, taking the reading, recording the temperature. Use the collected data to perform the calculations necessary to complete data table number 2. Yep, and the calculations are all pretty easy. If we scroll down to data table number 2, we're just looking for changes in volume. So you're just measuring the dye within that. All right. And yeah, so they have a little warning here. So if using 2 9x13 pans, place 2 respirometers in one and one in the other, but make sure that the temperature is about the same. And that's why it's good to use one bigger pan if you have it. But yeah, so that's the lab. Obviously, I'm not going to make you guys sit here and watch me for 20 minutes do this. I'm going to do this by myself. But the biggest thing here are cleanup, right? So keep all of your PPE, take the stoppers out of the respirometer, pour the water from the vials down the sink, and drain, right? Make sure that any seeds or beads aren't going into your drain, obviously. Rinse the seeds and beads with water. Discard everything else from the trash. Pretty much everything can go in the trash. Just be very careful with the potassium hydroxide. Yep. I would say you could keep the glass vials, keep the rubber stoppers. Never know when you might need them. The glass pipettes can go into your recycling and dispose of your gloves. Yeah, so again, if you have food dye, use it. If not, you can use a little flashlight trick. So you can just kind of shine your flashlight and you should be able to see water come in. But yeah, so if you have any questions, please feel free to reach out. And yeah, enjoy watching some cellular respiration for 20 minutes. All right, guys, take care.